Hi friends, today we are going to solve Sherlock and Anagrams problem from Dictionary and Hashmap subsection of the interview preparation kit. Two strings are anagrams of each other if the letters of one string can be rearranged to from the other string. Given a string, find the number of substrings of the string that are anagrams of each other. So basically one string is given. We would have to find how many numbers are anagram of each other. So for example, in the section of MOM, so there are two pairs which are going to be anagram of each other, M and MO and OM. So both of them are going to be anagrams of each other. This is a very interesting problem to say the least. So here we have to count how many anagrams are possible. So there would be one function which is going to be 0. There would be two for loops. So one for loop would be counting from say M, and another would be, for example, in case of MOM. So for example, the ith value would start from 0 and jth value start from I plus 1. This is the basic idea of the two for loops, and it will keep on counting. So for example, during the first iteration, the ith value would be 0 and jth value first would be 1. M and O are not anagrams. Then the second iteration of the uh, jth value would be 2. And in that case, M and M both would be mom. Now, in the third scenario, now we have to increase our step. So from M to O, so we have to create a function where we can calculate the total number of substring to to calculate or to count during iteration. So for example, during there needs to be some variable which would basically help us to select how many words of the substring we're going to check. So for that we'll be creating a iter function. So I iter is going to be 0. So for the first case iter was 1. So for the first case iter was 1. For the second case iter is going to be 2. So in this case mo mo from ith value would be mo and jth value would be om. So if we sort both of these values mo and om, then we would be finding that both of them are anagrams of each other. So we'd be increasing our count value by 2. Similarly, there would be a situation when iter value would be 3, but in that case we have to create a function where iter would be stop incrementing once it has reached the length of the string. So that's the basic idea. So while iter not equal to length of s, now the two for loop for I in range of 0 to length of s minus 1, because the last value you're not going to calculate, and for j in range I plus 1 till length of s minus iter plus 1. So this is the basic idea. Now we need to write our code. So if I talked about sorting those values. So if this is called slicing and dicing. It's a very popular Python operation. So if I plus iter So here, if both of them after sorting those values are the same, then we would increase our count value by 1. And once the for loop is ending for both I and j, at least for the jth value, if the for loop ended, then we'd be increasing our iter by +1. And in the second iteration, it will take two strings, two words at a time. In the similar, it will keep on progressing. So the logic of this problem is pretty easy. Just you need to understand how you're going to do this. So always remember these 3 steps if you're going to check whether values are anagrams of each other or if substrings are there in the same word. So in that case, you will have to use 3 for loops or one while loop and 2 for loops. It could also be done using 3 for loop. It would pretty much the same thing. So the complexity of this problem is going to increase considerably amount of times. Its complexity would be easily bigger of n cube, and plus we are also sorting those values, so it would again add some more complexity. So it's not a very optimized solution, but I don't know, but it worked, so I didn't thought of changing it. But if you guys have a better way of solving this problem, I'm pretty sure everybody would have a better way of solving this. So please comment below. I think that would be really helpful for my own knowledge also. So let's run the code. I think it would pass easily. So here the complexity of this problem is more than big O of n cube. So if you have a way, or if you can solve this problem in big O of n square, please comment below or maybe share some links which would be easier for anyone to understand. So for me, I would like to have C codes which are easy to understand. That is really helpful. And as always, let's submit the code. It passed all the test cases successfully, and and thanks for watching this video, and stay tuned. And don't forget to share your feedbacks. That would be really helpful to improve the contents in the upcoming videos.